24 is applying these derivative rules. So I have 6 rules listed above. Let's go ahead and start with 2039. See if you can. You basically are just trying to find that u value and then putting it into your derivative formula. And then sometimes you may have the need for product rule. So see if you can spot when there's a need for that. So I'll pace us through this page, but if you guys can start with 39 and 44 first, and then we'll compare our answers. You can also check the key with the next page. So 39, we're applying the rule u prime over the square root of 1 minus u squared. That 2 is coefficient, so that 2 is not going to go anywhere. My u value is x minus 1, so u prime of x minus 1 is just going to be 1. And then it's 1 minus u squared. I'm just putting the 2 times 1, merging it in the same fraction, but either is fine. Okay, next up with 44, we know our u value is square root of x, but let's rewrite that square root of x as x to the 1/2 to kind of get it ready for our u prime, where we're going to apply power rule here. So our tangent is u prime over 1 plus u squared. So u prime, 1/2 x to the negative 1/2, 1 plus u squared, 1 over 2 root x, all over 1 plus x. You can leave it in this form. You can also multiply by the reciprocal and merge it into, reduce it out of the complex fraction. Any questions? 39 or 44? Right, number 46, hopefully we see a need for product rule there. X squared is one thing, arctangent of 5x is another thing. They're being multiplied together. So go to the product rule, f prime g plus f g prime. Next up, 47 is chain rule. Any questions up to 46? All right, 47. All right. Okay, so sine's derivative is cosine. Outside's derivative. And as we take the outside's derivative, we don't make any changes to what's inside here. And then we move into the inside portion. So arc cosine looks a lot like arc sine. It's u prime over square root of 1 minus u squared, but with a negative in front. So our u value is t. T's derivative is 1 with a negative attached. Okay, usually with chain rule, we want to go one step further and try to resolve this piece here. So we're going to create a triangle and fill out that information. This represents theta. So we're looking to see where is cosine of t equal, sorry, where is cosine of theta equal to t? Over 1. So adjacent over hypotenuse, so t over 1, Pythagorean theorem, a squared plus b squared equals c squared. We get square root of 1 minus t squared. But we're asking for cosine of theta, and cosine of theta is going to be the same thing, t over 1, which is t. So nothing's going to change. It's going to be just t. And actually, with this scenario, we could avoid the triangle because it's just the cosine of our cosine. So these are directly inverses of each other, meaning that these will cancel each other out, leaving us with just t. And that's why we get the same thing as before. But we can also go through a triangle for every one of these and just confirm that we're getting our answer. So t times negative 1 over root t minus t squared, which is be negative t over square root of 1 minus t squared. So we multiply these parts together after we clean up this cosine of r, cosine of t. Number 50, we have two separate rules here. You got the arctangent rule. You also have natural log of u. So as a reminder, natural log of u's derivative is u prime over u. Okay, so we have two separate rules, and then we can merge those two separate derivatives at the end. Or not merge them, just put them next to each other. Okay, try that. So first portion is u prime over u, or natural log. T squared plus 4's derivative is 2t. And then u value is t squared plus 4. Arctangent, the rule is u prime over 1 plus u squared. I'm just going to get that t over 2 ready for power rule. I'm just going to pull that 1/2 in front, make it 1/2 t. So coefficient is going to stay 1/2. It's not going to go anywhere. And my u value, u prime, 1/2 t's derivative is 1/2. All over 1 plus u squared. The 1/2 times 1/2 is 1/4. So I can make this 1/4, and then we don't have to do undo the complex fractions. So let me just write out what I have. E squared plus 4. So some variation of this is good enough. Okay, let's have a chance to practice our derivative rules. So on page 27, you guys, we had a chance to try it one time. There's another, just go to blank page before, after that, page 28. And I'm going to have you guys copy this down here. But I just want you to watch me go through the process. And then after, well, yeah, first write down these 6 rules, or these 6 derivative functions, or 6 functions, ArcTrig functions. And then watch me do it. And then after I erase it, then have you guys try it. So hopefully, you know, if we do this every day, you guys should feel pretty comfortable by the time we get to our test day. So really, it's just the first column that is giving us, that's unique. Okay. And we know that all the derivatives will have a numerator and denominator. And then u prime will go in all the numerator space. The denominator all have 1 and u squared in it. And our tangent is the simplest looking one. It doesn't have absolute value. There's no square root. There's no minus sign. It's just 1 plus u squared. Or u squared plus 1. Doesn't really matter. So I start there because I know that everything is going to be involving some sort of a u or 1 plus u squared. After this, I go to arcsecant. Arcsecant is the most complicated looking one. It's got the absolute value. It's got the square roots. And it has u squared and 1 in it, but they're subtracted. And the way I remember the order is it's u squared minus 1 is the fact that the u's are next to each other. So that helps me remember, okay, it's not 1 minus u squared, it's u squared minus 1. And if I see that in front of me, I know that this is very similar to what I'm going to see with arcsine. It also has a square root. It also has u squared and 1, but the order is a little bit different. So if I see this order in front of me, I can adapt for the change in order for arcsine. And then once I have these 3 in front of me, I can just copy them over from the ones I see to the left and just put a negative u prime for all the numerators. Okay. I want you guys to have a chance to try it, so don't try it yet. But I'm going to erase this and have you guys try it. Okay. Fine. Okay, so take a shot at writing out these rules, see how much you remember. If you don't get everything right, it's okay. We have multiple days to practice this. Okay, let's see how we did. Okay. Let's go to our test review. Packet I just picked up beginning of class. If you turn to the very back of the packet, page 30. Here's an idea of what you can expect to see on the test. And we're going to be working towards these types of problems. So inverse trig derivatives, we just got through working through them, being able to memorize and apply those 6 inverse trig derivative rules, and sometimes they could be within product rules. So being able to go through that. Implicit differentiation involving trig. You guys demonstrated that on the quiz, so this is a quiz topic. Particle motion problem, we'll do some of that over the course of these next few days. Related rates trig, we did that yesterday, the day before, right, where we have to draw a separate triangle and find that ratio. So I have a bunch of problems in the test review, so we'll get some more a chance to continue to review that. Mean value theorem, trig derivatives, average rate of change. We'll we did mean value theorem when we did curve sketching, so we'll practice that at the beginning of class. Trig curve sketching problem, where you have to do first derivative test per concavity, create your sign lines, and then find your order pairs and sketch your graph. You'll get to use your calculator to confirm your steps, but yeah, so you get to use your calculator for that. But I do need to see all your steps as well. We need to make sure we know our unit circle values. We need to make sure we know our derivative rules, but just for the kind of like the basic, the big functions like natural log, e to the u, power rule, trig derivatives, and then the inverse trig derivatives. Those are, so none of the more obscure ones, like a to the u and log base a to the u, log base a of u. You need to know that when we do our trig, our derivative rules quiz, but it's not going to be on the test. Okay, so these are the things that we're working towards. We've gone through most everything, maybe except for the particle motion problem, but you know, we have these 5 days to go through this test review. And if we finish this, and I'll come up with some more problems for us to practice with. All right, let's go to page 1. We're going to skip limits, so I'm not going to put limits on the test, so I'll skip that. Let's go to number 2. All right, number 2, determine whether Rolle's theorem can be applied. Now, Rolle's theorem is just a variation of mean value theorem. It's just that the slope between the two endpoints has to be 0 in order for us to move forward with Rolle's theorem, but it starts off the same way. Same formula, same conditions. Okay, so first is recognizing that secant does have asymptotes, but the negative pi over 4 to pi over 4 is not going to interfere with those asymptotes. So we just have to make sure we state our conditions. Our function is continuous on the closed interval with brackets and differentiable on the open interval with parentheses. So here's our formula. F of B minus f of A over B minus A. This is my average rate of change, and I'm setting it equal to the instantaneous rate of change. So we're trying to figure out, can I show that there's a slope of 0 between the two endpoints? If there is, then there must be a place on the actual curve where the graph is also experiencing a slope 0 somewhere along the path of the graph. I like to write it out this way so that we're kind of forced to deal with the algebra portion first. So we're just going to plug in our negative pi over 4 and pi over 4 in for A and B, find the y values, find the slope. And once we're done with that, then we can move into the derivative portion. So my A value is negative pi over 4, and my B value is pi over 4. Okay, so I need to spend some time using my function here to figure out these order pairs. So I'm just going to step to the side here and find those y values so that I can plug them in. So let's do f of negative 4 first. Negative pi over 4 first. So secant of negative pi over 4. I like to think in terms of cosine. It just feels more familiar to me, so I could just rewrite it as 1 over cosine of negative pi over 4. If you don't recognize negative pi over 4, you can always add 2 pi to it to get into that 0 to 2 pi range. That feels more familiar. So if I add 2 pi to negative pi over 4, it's basically 8 pi over 4 plus or minus pi over 4, which is 7 pi over 4. And we know that now cosine in the fourth quadrant is going to be positive. We get root 2 over 2, and root 2 over 2 in the denominator. Flip it, the same thing as 2 over root 2. So we know f of negative power 4 is root 2 over root 2. F of power 4 is going to be the same thing. Secant of power 4, 1 over cosine of power 4 is also 2 over root 2. So they end up being the same y values. So we get 2 over root 2 minus 2 over root 2 all over 2 pi over 4. Now, it doesn't matter what the denominator is. My numerator is 0 because these cancel out. So 0 over 4, sorry, 0 over 2 pi over 4 will just be still 0. So our condition is met. This is what Rolle's theorem tells us, that in order for us to guarantee a slope 0, my two y values have to end up being the same in order for them to cancel out. So Rolle's theorem does apply because we can guarantee a slope 0 now that the endpoints is giving me slope 0. So now all I need to do is to find f prime, set f prime equal to 0, and then solve for x. So I have my 0 guaranteed. Now I just have to find my derivative. Secant becomes what? Secant tangent, right? So I want to know, where is secant tangent equal to 0? Now, anytime I'm setting a function equal to 0 or something equal to 0, and eventually we're going to get some numerator denominator show up because we like to work in terms of sine and cosine. And if you get a numerator or denominator equal to 0, you're always setting the numerator equal to 0. The denominator equal to 0 is something else. So secant is 1 over cosine. Tangent is sine over cosine. Merge that together, and I get sine over cosine squared x. But I'm really just caring about what the numerator is giving me. It's technically 0 over 1. And so it's really just the numerator that we have to worry about. We just have to worry about where is sine equal to 0, and that's going to tell us where this graph is going to experience a slope 0 that is going to land somewhere between these two endpoints. So where is sine equal to 0? Well, sine is equal to 0 at 0, pi, negative pi, 2 pi, negative 2 pi. Okay. We just need to find the one that lands between negative pi over 4 and pi over 4. And so it's just going to be 0. 0 is the only x value that's going to land between these two endpoints. Okay, number 3. Number 3 is a mean value theorem problem, which is essentially the same process, same conditions, same formula. It's just that this doesn't have to end up zeroing out. It can end up being a different slope value. Mean value theorem can also be slope 0, but doesn't have to be. Rolle's theorem has to be slope 0.
Okay, so let's go through our conditions. Same conditions as Rolle's theorem, continuous and differentiable. Now sine is easy. There's never any asymptotes with sine or cosine, so it's always smooth, always continuous. So there's no need to check anything. Just have to write out our conditions. Okay, so we're going to spend the time to plug in the endpoints, figure out what slope we're trying to target. And then once we get that slope, we can find the derivative, set the derivative equal to the slope value, and then work towards solving for the location where this graph is going to experience some guaranteed slope along this interval. Okay, my A value is 0. My B value is pi. I'm just going to plug in, go through my slope process here. Okay, if I step to the side here, f of 0 is just going to be 2 sine of 0 plus sine of 0, which is just going to be 0. F of pi, 2 sine of pi plus sine of 2 pi. Now sine of pi and sine of 2 pi also is 0. So we actually do end up zeroing out. This could have been a Rolle's theorem, but mean value theorem also works. So we get 0 minus 0 over pi, which is still going to be 0. Okay, everybody see that process? I mean, we got the same result between 2 and 3, but this had to be slope 0. This could be slope 0, but doesn't have to be. So it still passes. So now we know that this graph must experience a slope 0 somewhere along the curve, and then we're going to use the derivative to help us locate where this graph is experiencing a slope 0. So let's find the derivative. So we have this portion finished. We're just now working on this portion here. So f prime, 2 sine becomes 2 cosine. Sine of u becomes cosine of u times u prime. Okay, so we have our derivative. We have our target slope. We're just going to set them equal to each other and go from there. Now, I want to get this out of double angle so that I can actually go through my potentially factoring process. So there's a double angle identity for cosine 2x. Now, if a double angle identity shows up on the test, I'll give you those identities. I won't ask you to memorize them. So there's an identity for cosine 2x in terms of cosine, which is 2 cosine squared x minus 1. So I'm going to take that, substitute it in for the cosine 2x, and that gives me everything at the same level for me to combine different pieces here. So I see a cosine squared, I see a cosine, I see a constant. I'm expecting trinomial factoring here, so I'm gonna start getting them in order here. I can factor out a 2, so that I can ignore the 2. That 2 is now a coefficient. It won't impact my solution here. But this is a trinomial factoring. If you prefer not to factor in terms of sine or cosine, then you can just do an easier version of this problem, which is 2x squared plus x minus 1. Let's factor this. And then once we factor it, we can bring the cosine back into our factored form. So multiplies to be negative 2, adds up to be 1. Okay, so let's bring back cosine. Okay, now that we have our factored form set equal to 0, we can set each part equal to 0 and solve for x. We're looking for an x value solution that sits between 0 and pi. That's our goal. And we're at this stage, we're guaranteed to find one, at least one. So where's cosine equal to 1/2? Going to be in that pi over 3 family. So x is pi over 3. First and fourth quadrant, 5 pi over 3. Where's cosine equal to negative 1? Pi and negative pi. Now, we want to find the c value that sits between the two endpoints. Even though pi lands at the endpoint with mean value theorem and Rolle's theorem, it has to sit between. So endpoint is not close enough. So negative pi and pi are out. 5 pi over 3 is clearly outside the interval, but we do have a guaranteed solution at pi over 3. So at pi over 3, this graph is guaranteed to experience a slope 0. And we know we can guarantee that slope 0 because our endpoint, our condition passed, and our endpoint produced a slope 0. Okay, we're largely not going to have any homework because we're do everything in class. But at the end of the unit, I will ask to look over your packet. So if you just do everything in class, I'll give you 100 for this unit for doing all the classwork problems. Okay, but we have enough days where I think we can just do everything in class, not have to do anything at home. Okay, all right, go get your phones. Okay, great. Thanks. It was like
Didn't take that. Was shoot down and yeah, you know, it comes up to rendering.
Yeah.